Thank you so much, Pramila. Actually, on that same note, I think this is a great time and opportunity to thank Pramila because all this wouldn't be possible and everything that she does to put this together in a very affordable and organized manner with food and everything provided and just her passion to make this available to everybody in this. I just want to take this time to just give her applause. Thank you so much, Pramila. So our next speaker, Dr. James Adams. Okay. Dr. James Adams directs the Autism Asperger's Research Program at Arizona State University. He's also the president of the nonprofit Autism Nutrition Research Center. That's www.autismnrc.org. And he's the president of the Autism Society of Greater Phoenix. He's the father of an adult daughter with autism. You can find more info on this talk and his recommendations for autism families, and they're all available at www.adamsautismresearch.com. A little bit about today's talk. Today, Dr. Adams will be talking about microbiota transplant therapy. He'll be reviewing the GI problems and the GI treatments for ASD. Next, he will discuss the results of the phase 1 clinical trial of an investigational new drug involving 2 weeks of oral vancomycin to kill unhealthy gut bacteria, followed by a bowel cleanse and then standardized human gut microbiota data to create a healthy GI microbiome. Maybe Dr. Adams will speak more about this. He's also speaking again at 3:45 on nutritional interventions. So thank you so much, Dr. Adams.
Okay, thanks very much to Prem and everyone for organizing the conference, and thanks very much to our first speaker for just doing a great introduction to the microbiome and a lot of the challenges out there. We still have a lot to learn. I want to give special thanks to my 2 collaborators, Rosie Crouch-Malnick-Brown and Daewoo Kang, who have done a lot of the microbiome work and helped us with the analysis, as well as everyone else in our team. But there's a lot of information available on our website. That's our official ASU website, and there's a lot more recommendations for parents on my personal page. I do need to make a disclosure that several of my colleagues and I have several patents related to the use of FMT or specialized probiotics for treating a variety of conditions, including autism. And so we've also received research funding from Cristovo. That's the company that makes the full spectrum microbiota that we used in the study I'll be talking about. And we are part-time consultants with them because we're helping them improve their technology. The reason this is important, the reason we filed the patents, is because I'm a father of a child with autism. I just want my child to get better. But if we don't have patents out there, we can't get companies to invest money to go through phase 1, phase 2, phase 3 drug trials. It typically takes about $1 billion to get a new drug to market. So it's not cheap, it's not easy, and you have to have a lot of justification. So patents are essential in order to interest pharmaceutical companies in doing this. So the good news is we have some interest there. Okay, so you've heard a little bit about the role of human gut microbiota, but I want to say a little bit more about that because historically in the autism community, people have been looking for what is the bacteria that's causing a problem. And I think that's actually a misconception, that what we're finding is not one bacteria is causing a problem, we're finding rather it's a lack of many beneficial bacteria. So it's important to understand what do our beneficial bacteria do. Our beneficial bacteria break down and help us digest food. Plant polysaccharides. For example, dietary fiber is consumed by bacteria and converted into short-chain fatty acids, which are the primary food for the colon. The cells of your colon get most of their nutrition from the short-chain fatty acids from the bacteria, not from blood supply to them. Because most people in the United States and Western world do not consume enough fiber, then your cells of your colon are not getting enough short-chain fatty acids. They are literally starving for nutrition, and that's why we have such a wide variety of GI disorders in the United States and Western world. It's what you would expect to have. So it's a lack of these beneficial bacteria that is causing a variety of GI issues. These gut bacteria help to promote GI motility, to keep stool moving through the intestines. They produce key vitamins, and I'll talk about that later. We've measured levels of every vitamin in children with autism, and one of the most key ones, biotin, is produced largely by your gut bacteria. They're also critical in competing against pathogens, all right? So why is it that when you eat a hamburger, you don't catch, one person gets E. coli, but someone else doesn't when many people are exposed? Do you have the right gut bacteria to protect you from those? On the right hand are the bad guys who can cause a variety of GI problems. They can produce a variety of toxins, some of which are life-threatening and can kill you. They can disrupt your immune system, and they compete against the beneficial bacteria. So what we want is a balance. We want a balance, a rich variety of beneficial bacteria and minimal amounts of these pathogenic bacteria. But it's even more complex than that. Some bacteria, like E. coli, might be good at a low level, but harmful at a high level. So it's about the balance. We need the right amount of each of the different bacteria. So in general, humans have of order 1,000 different species of bacteria in their gut. In general, many studies have suggested that higher levels of a number of species, higher diversity, is related to a healthier gut, less GI symptoms. We published a study in 2013 that found that children with autism have about 25% less species of bacteria than other people. So they're missing about 200 to 300 species. But it's different. Some children are missing these 200 to 300 species. Some children are missing these 200 to 300 species. So there's some difference. I have to caution you, there's a lot of conflicting information out there on GI studies. And part of the biggest problem is that the way most studies are done is they are looking at 1,000 different species. And they say statistically, is this one higher or lower than this one? The problem is they don't adjust for making 1,000 different comparisons. So if you just choose a p-value of 0.05, if you look at 1,000 bacteria, on average 50 would show up as abnormal. Just false fluctuations because you're looking at 1,000 different comparisons. You aren't using rigorous enough statistics. So the statistics I'm going to share with you, we adjust for making hundreds or 1,000 different hypotheses so that we're much more confident in our results, and we've actually replicated our results in 2 or 3 studies. So historically, people have searched for what are pathogenic bacteria, but I think that's a mistake. I think the real focus should be on the beneficial bacteria because it's a lack of those that seems to result in a plethora of different pathogens. Some kids get one pathogen, some get another, but the real issue is not the pathogen. The real issue, we think, is a lack of the beneficial bacteria. Our study, and we've replicated this 3 times now, have shown that children with autism have unusually low levels of Prevotella, which is associated with healthy, fiber-rich diets. If you look at people on traditional Aboriginal diets, very high amount of fiber, vegetable intake, you see that those individuals in Africa, for example, half of their gut bacteria, 50%, is Prevotella. If you look at people in the United States, it's less than 1/10 of 1% of their bacteria is Prevotella. Very low levels of fiber intake. Also, a study just came out a couple weeks ago showing that in Americans, the people who exercise more and more, the more you exercise, the more Prevotella you have. People in Africa on traditional diets are also probably not driving around in cars, but walking a fair bit, and so again, getting more exercise. So it's a complex interplay to really understand what's going on. So what does this mean in terms of treatment implications? If people with autism seem to be missing several hundred different species, and Prevotella we found anti-correlated with a variety of pathogens. So if you had low levels of Prevotella, you tended to have high levels of abnormal gut bacteria, and vice versa. When you have a high level of pathogens, you have low amounts of Prevotella. We can't say which is the cause. Is Prevotella protecting against the bad bacteria, or is it destroyed by the bad bacteria? We can't say that yet for sure. But it tells us that if you're missing hundreds of species, then we need to reseed with a broad spectrum probiotic. The problem is probiotics that are commercially available typically contain only 1 to 10 strains. So you aren't going to be able to replace several hundred strains if you only have 1 to 10. Right? So part of the problem too is that the strains that are commercially available are strains that grow in air. They're aerobic bacteria. 99% of the bacteria in your gut are anaerobic bacteria. They grow where there's no oxygen in your gut. So we are giving probiotics that are cultured almost all on milk. They grow great in milk. They are not the right bacteria for your human gut. After you stop taking probiotics, within 1 to 2 weeks, they're flushed out of your system. They don't grow there. What we need to do is give the natural bacteria that are naturally present in the human gut, the ones you primarily inherit from your mother. And so what this suggested to us is that we should be doing a transplant of beneficial bacteria from healthy donors who have healthy gut bacteria. So we went ahead and proposed doing this, a trial of MTT for autism. Now I should back up a bit, and let me just take a show of hands. How many of you are familiar with C. diff infections or have heard a little bit about it? So C. diff is a very nasty gut infection, especially strikes people who are elderly in nursing homes or hospitals. It's a very nasty strain, causes life-threatening diarrhea. The standard treatment is with antibiotics, but then it often comes back again and again. When it comes back a second or more time, then the FDA allows it to be treated with a fecal transplant. Fecal transplant, 1 dose, 1 time, 90% cure rate, and it virtually never returns. People go from dying, a life-threatening diarrhea, to within 2 or 3 days, their symptoms are gone. It is dramatic. It is rapid. It is also extremely misleading because that's very different from the condition for autism. We find kids with autism often have these GI symptoms since infancy. They've had these GI symptoms very long. So we worked with a GI doc from Australia, Tom Brody, who's treated over 5,000 people with FMT, more than anyone in the world. And he found in the kids he treated with autism, it was much harder to treat autism than C. diff. It was, in fact, some of the hardest patients he's ever treated. So he treated them daily for 3 months, a much more invasive, a much more extensive preparation. So now FMT is being used to treat some other types of GI conditions like ulcerative colitis, Crohn's disease, constipation, with some limited effect because you're giving just 1 dose 1 time. We are recommending a radically different approach. So that's why we don't call our treatment FMT. There are several differences. We call it MTT, microbiota transplant therapy. To clarify, we are not doing single dose. We're doing daily doses for many weeks because we think that's what's needed. So in order to, the FDA classifies human poop as a drug, as a biologic. So we have to go through phase 1, phase 2, phase 3 trials before it can be approved by them, just the same way they treat blood products, right? Because there is some potential danger there. So the goal of our study was to do a pilot study of 18 children with autism, ages 7 to 16. We wanted to do younger children, but the FDA said, you know, most FMT studies have been done on adults, so let's be cautious and only do somewhat older children. We looked at a combination of 3 therapies, which we think are very important. We gave oral vancomycin, which is a medication, an antibiotic, a very potent one, that is not absorbed into the rest of the body. It stays only in the GI tract. And we use that because there was a study back in 2000 by Sandler that showed if you gave oral vancomycin for 8 weeks, GI benefits greatly improved and autism benefits greatly improved during those 8 weeks. But when they stopped treating, and many of those kids then got a standard probiotic, they lost their benefits. They lost their GI benefits. They lost the autism benefits within weeks. That you had wiped out the bad bacteria. Those bad bacteria were causing problems, but they were not able to successfully reseed. So a good analogy I like to give is if you have a garden filled with weeds, Giving an antibiotic is like pulling all the weeds. But what happens if that's all you do? Those weeds are going to grow back. What we want to do is pull all the weeds and then replant with good seeds. If you replant with standard probiotics, imagine you're planting corn, you're never going to grow beets, wheat, barley, etc. We have to replant 1,000 different types of seeds. So that's our goal, is to first use oral vancomycin to wipe out the bad bacteria. We use MoviPrep, which is a bowel cleanse. If you've ever had the pleasure of a colonoscopy, you can imagine drinking this liquid that really flushes you out, because we want to remove as much of the microbiome as we can. We want to clean a garden as we can, and then we reseed with a lot of healthy bacteria. Okay? So that was our transfer protocol. 2 weeks vancomycin, much shorter, but it's actually the standard treatment is only 10 days, so it was enough. And we also used a day of partial fasting, because again, we wanted to have as little food in the GI tract as possible. Then we gave very high dose microbiota. Half the kids, 12 of the kids took it orally, 6 took it rectally, because we didn't know which route was better. For C. diff, rectal is slightly better, 90% cure rate. Oral, you can imagine taking raw stool orally through a nasal gastric tube. It's about an 80% cure rate. But we used a highly, highly purified form. That's, again, something that specializes our microbiota transplant therapy I'll talk about. And then we did daily dosing for 7 to 8 weeks. A microbiota source is a full spectrum microbiota. All right? That means we take very, very healthy donors who are very carefully screened, just like the American Red Cross screens blood donors. And then in addition, we check GI history. We make sure they have a normal body mass index. We check a wide variety of things. The screening process is so rigorous, 90% of the US population doesn't meet our criteria. And sorry, that's the reality. We take the very healthiest people and then purify it extensively so that only bacteria is left. So it's over 99% pure bacteria. You can smell it. We have them mix it in chocolate milk because they looks a little brownish. You can imagine why. And the kids with autism just drink it down. And I smelled it. I wasn't allowed to taste it, but it was allowed to smell. It smelled quite normal. Okay? And then, so it's essentially a super probiotic of 1,000 or more species. That's what it essentially is. So the participants were 18 children with autism. They had moderate to severe GI symptoms. Most had constipation, sometimes alternating with diarrhea, but some had only diarrhea. We excluded the very lowest functioning children because this is a first trial and the FDA wanted to make sure the children could communicate any problems that they had with us. In terms of compliance, one of the amazing things about this study is all 18 of the children completed the study. There were no dropouts. It tells you it was very well tolerated. The MoviPrep was actually the hardest part of the study, getting the kids to drink this nasty tasting liquid. And a few of them didn't drink all of it, which is unfortunate because then a few of them were not as cleaned out as they could have been. In a few cases, the mom and dads tried to have the kids be fasting. Can you imagine keeping food away from your child with autism for a day? Yeah, so a couple kids snuck a cookie here or there, so it wasn't perfect, but pretty good. But we think that did have some effect. Orally, the high dose was very well tolerated. 12 of 13 kids drank it down. One child who'd also had a lot of problems drinking the MoviPrep vomited, so she was switched to rectal, and they were fine. The rectal we gave, our developmental pediatrician was amazing. The kids just laid down, very slowly inserted the tube very deep into their bottoms, put it in there very slowly. There's a special rotation procedure to get it deep into the colon. We had the children lay prone for an hour in the room, and then the parents carried the children prone to their car, prone to their home. We wanted to keep that good stuff in them as long as possible, several hours, in some cases up to 24 hours. And we wanted to keep that good bacteria in there as long as possible. The oral low dose, very well tolerated, no problems at all. Vancomycin, one child had a rash. We discovered it was due to the natural orange flavoring, so we removed the orange flavoring. They were fine with it. The microbiota, no problems. We did extensive chemistry panel and blood cell count. No hint of any problem with liver, kidney function, etc. As we expected, FMT is a wonderfully good track record. There was a very interesting adverse effect, just what had been reported back in 2000, and we told parents to expect this. It's a huge clue. 12 of the 18 children had a behavioral reaction to the vancomycin. It started almost immediately upon taking the vanco. Within 1 day, or sometimes up to 3 or 4 days, it started. It lasted usually just a day, sometimes 2 or 3 days. In one case, it lasted 3 weeks. Generally, there was a mild to moderate increase in hyperactivity in some of the children, or mild to moderate increase in tantruming. So it got worse for a day or two, and then it got better. Why is that? Because if the bacteria are causing these problems, they're slowly releasing toxins. When you kill the bacteria, all the toxins are released all at once. You'd expect a surge in whatever symptom that toxin is causing. And then when the bacteria are killed and no longer present, no more toxins are being released, and then the symptoms should be reduced. We now know which children were more likely to have that adverse reaction. Just as we suspected, the children who had worse of those symptoms, presumably more of the bacteria causing those symptoms, had a worse die-off reaction. So this is very much what Sandler et al. Found in their study. Okay. So we looked at GI symptoms using a scale called the GSRS. It's not developed for autism, but it actually has 15 different items on it, and it covers all the autism symptoms very well, we found. So the first 2 weeks with the vancomycin, and you can see there was some reduction in GI symptoms. Now again, this is what's called an open label study. There was no placebo control. There's probably some placebo effect here, all right? But also the parents were tracking the child's poop every day, and that's a little harder to fake. But you saw overall good reduction of GI symptoms. A 1 means absolutely no GI symptoms at all. So by this 2 weeks in, the vancomycin had some benefit, but slowly, gradually, the GI symptoms improved. This is totally different than with C. diff. With C. diff infection, you see an improvement in 2 to 3 days. Symptoms are gone. Here it's slow, gradual improvement over about 5 to 6 weeks. These children had all had GI symptoms since infancy. These were very long-lasting symptoms, probably a fair bit of inflammation. And then I continued. Now, week 10 is when we stopped treatment. And then we crossed our fingers and hoped, would the benefits remain, or would we lose them like what had happened in the Sandler study? And sure enough, the benefits remained, that 8 weeks later, there was no loss of GI benefits. That was just thrilling. That meant that we had successfully implanted the bacteria. We looked at the individual children. 16 of the children had a 70 to 100% reduction of GI symptoms. One child had only a 30% improvement. One child, who was one of the most severely constipated and most severe cases, had no change. And that was a child who had an incomplete bowel cleanse. But previously, at the start of the study, she could only poop standing up. And she managed to start pooping in the toilet. So there was for some of the parents, they may recognize that's a good improvement, but not something we were statistically tracking. If we look at each of the 5 subscales of the GSRS, abdominal pain, the blue was at the start of the treatment, blue is at the end of treatment, and red is 8 weeks later. So the pain was mostly gone, all right? The second scale is reflux, which very few children had. Next scale is indigestion, and so great improvements in indigestion. Next scale, I'm not sure why it's not showing, is diarrhea. So huge improvements in diarrhea, huge improvements in constipation. These are very different symptoms. Isn't it fascinating that one treatment could improve both diarrhea and constipation? If your stool was too loose, it firmed up. If it was too hard, it softened. It became, as Goldilocks said, just right. Okay? Here's the beautiful pictures that we use to guide our parents to rating. So a lot of them started off at type 1 or 2 very hard, or type 6 or 7 very soft, and by the end they ended up with a beautiful type 4. Parents were so thrilled. This is a way to explain it to you, that this is a percentage at baseline. Blue is the percentage of days, 35% of the days the kids had no stool. They were constipated. Red is a number of percentage of days they had very hard stool. Green is a percentage of days they had a very loose stool. What you could see is by the end of treatment, there were many fewer days of hard stool, many fewer days of liquid or soft stool, some reduction in percentage of days with no stool. But it doesn't take much. If you're pooping every 2 days instead of every 3 days, that's a lot better pain-wise. Right? So even though it doesn't look like a big difference, from the parent's perception of the child's pain, it was a big reduction in pain just because it was a little more frequent. And again, after treatment stopped, 8 weeks later, benefits were still holding. We looked at the parent's global impression of autism symptoms. This is a simple scale of 17 different items. And on a scale of no change to slightly better is 1, better is 2, much better is 3. It also goes negative, but no one got worse. Isn't that great? No one got worse. What we saw is that overall there was a slow, gradual improvement, pretty steady during the first 10 weeks. And then we checked again 8 weeks later, and the benefits, according to the parents, were still the same. But we arbitrarily stopped our study at 10 weeks. We were guessing as to the right duration. What if we had gone longer? Would that number have kept going up? We don't know, but we're going to find out in our next study. So in terms of what the parents had to say, 4 of them said their child was much better, 8 said their child was better, 5 said slightly better, 1 said little or no change. So we didn't help every child the same amount. We're also guessing about dosage. This is our first study. We're guessing dosage. We're guessing duration. This is very useful information. So our next study, we hope, will be even more successful. To look at what are the specific symptoms that primarily changed, again, it was stools and GI symptoms that parents reported having the biggest improvement, but also almost as much improvement in speech and language, in attention and focus, and social ability. You know, if you're not in pain and discomfort, if you're not wondering when you're next going to poop in your pants, you're going to feel a lot more pleasant and a lot more sociable. Okay? Better cognition and thinking, better play skills, irritability and mood, anxiety, eye contact. Now some of the later ones, again, it's an open label study, so I trust the higher scored symptoms more. But overall, very, very positive. Later, evaluate the children. And so at the start of the study, they were almost all in the severe range of autism. 15 is perfectly normal, as good as you can be. 30 is the cutoff, roughly the cutoff for autism. 36 is roughly the cutoff for moderate to severe autism. So what we see is about a 23% reduction in autism severity, according to the CARS, which is a very widely used tool by our evaluator. She's very proficient in it. She said she'd never seen as much improvement in this study as in any study she's ever done, and she's done quite a few. And 8 weeks post-treatment, again, all the benefits seem to be remaining. Looking at the aberrant behavior checklist, which rates problem behaviors, hyperactivity, irritability, social interaction. We found a reduction in problem behaviors, about a 27% reduction. Just one of these subscales, the ABC subscale in irritability, is the only improvement that was needed to get Risperdal and Abilify approved. We saw improvements in all 5 of the subscales, okay? And so we saw reductions in all those. If we look at each of the subscales, so we saw improvement in irritability, improvement in lethargy, in stereotypy or stimming, in hyperactivity, and in speech. If we look at the microbiome diversity, this is one of the most exciting areas for us because the rest, a lot of it is still open label data, but this is pretty hard lab data. So what we see here, the dotted lines in purple are the microbiome diversity of the children. So higher levels, more bacterial species. So you see the bar, which is the average. The orange dotted line is the level of our initial donor, their initial diversity, higher than that of the kids with autism. And the final donor actually had a higher diversity. The dotted line in green is the neurotypical children. And so we see at the start of the study, just like in 2 previous studies we've done, kids with autism had lower diversity. They're missing 200 to 300 species. After the FMT, then you're still right at the start. So the 2 weeks into the study, right after we've done the vancomycin, there's not much change because the vancomycin has killed off a lot of bacteria. But then 10 weeks later, after we've given them FMT, there's a huge increase in the bacterial diversity. There's a much greater improvement in the great improvement in the diversity. And this is actually looking at the genetic diversity. So there's actually a substantial increase in the overall genetic diversity of these bacteria. But most important, if we look at 18 weeks, the diversity is actually even better. It's as good or better than the neurotypical children. It's really fascinating. And so it's very, very powerful. One of the things to think about here is that we used one donor for the initial donor, another donor for the maintenance. And so if you're getting some healthy bacteria from one person, some from another, that's why we actually ended up with better diversity than one of our healthy donors. So it's pretty impressive. So to summarize, children with autism have abnormal gut bacteria, including a lack of beneficial bacteria. And I don't think I mentioned this before, so I'll say it again. In one of our studies, we had measured levels of every vitamin in blood of children with autism. We found they were especially low in biotin. And roughly half of your biotin comes from your gut bacteria. So kids with autism were missing key bacteria. When we then did a vitamin mineral supplement study, we could predict who improved. The kids who improved, the amount of improvement primarily depended on the amount of biotin and vitamin K they had at the start. If they had low biotin, low vitamin K, they had the most improvement. And we were really puzzled because these 2 vitamins have totally different function. And then we finally realized what the one thing they have in common is these are the 2 vitamins which are primarily made by your gut bacteria. So again, it was a major clue for us that kids with autism were missing some of the beneficial bacteria that are producing these vitamins. So our microbiota transplant therapy seems like a very promising method to restore normal gut bacteria and microbiome, and thereby improve gut symptoms and possibly autism symptoms. Now, one of the things I didn't mention is that I mentioned that our earlier studies had found that kids with autism had low diversity of gut bacteria. What I didn't tell you is it didn't matter if they had GI symptoms or not. Kids with autism with or without GI symptoms had low diversity of gut bacteria, which suggests to me that this might also be a very promising therapy for kids with autism who may not have pathogenic bacteria causing gut problems, but may have pathogenic bacteria producing toxins that affect neurological function. That's a hypothesis, but a very well-founded one, because back in 2011, we published the first study that showed the more severe the GI problems, the more severe the autism symptoms. We've also published several studies showing that kids with autism in their medical histories, the one major difference is they had an increased use of oral antibiotics. The more oral antibiotics, then the more is roughly twice as common in infancy during kids with autism versus typical kids. And oral antibiotics wipe out much of your normal gut bacteria. The more you take them, probably the more reduction of the diversity of gut bacteria. Each time you take it, it wipes out more and more. Another thing we looked at is we wanted to know, why did these children with autism have this low diversity to begin with? Well, where do you get most of your microbiome from? From your mother. So we had a hypothesis. We had the mothers of kids with autism and their children do a diet survey for us. And we found out, as we suspected, that there was one and only one difference in the diets of mothers of kids with autism and mothers of typical kids. What do you think that was? What I already told you, lower fiber intake, about 25% lower fiber intake, not enough fruits and vegetables. And so that was a big clue for us that was what we found about the kids with autism and their mothers. We also found that in this small study that the kids who had these GI problems, roughly 60% of them had been born by C-section. When you're born by C-section, then you are missing out on the transfer of bacteria from the vaginal tract, and also, I hate to say it, but birth is a very messy process, as I'm sure many of the women here appreciate, and there's some transfer of fecal matter into the mouths of kids too, because their mouth is positioned to be pointed towards that certain place. And so there's some transfer of bacteria from the vaginal as well as the microbiome, which is good for you. Now, you may think that this sort of microbiota transplant is a very radical therapy, but veterinarians have been doing this for years. That if you have a colt that has colic, the routine treatment is take some stool from mom, stick it up Junior's bottom, and it cures the colic. This has been routine for veterinarians for many years. So we're not that different. We're mammals also. So the point I want to make is this is a phase 1 study. It's open label, but it's clear we had a dramatic increase in the microbiome diversity. It appears the GI symptoms were greatly improved and stay improved. It appears the autism symptoms improved quite a bit as well. We've just completed a 2-year follow-up. Every one of those 18 participants was kind enough to follow up with us 2 years. I didn't plan to do that, but several of the families came up to me and said, Professor Adams, my child is doing so much better. When I heard that a few times, I said, well, we need to check how well this is doing. So we did a 2-year follow-up. I can't share with you the detailed results of that because we're writing them up now, but I'll say it's very promising at 2 years. So we do need more research. We are funded by the federal government now. We've received funding over $1 million to do a much larger study for adults. We hope to also do another study for children. These will be placebo-controlled studies, but the placebo group will then be shifted to the treatment group if they get the initial placebo. And so we think that will help validate. Now, you heard a lot in the first talk about metabolites. We want to know what is the bacteria doing, and one of the key ways they interact with our bodies is through metabolites. So we're writing up a paper now also on metabolites and what's very different in kids with autism. So we've done a very extensive analysis of that. But there's a reference here for the paper, which goes into a lot more detail. One of the common questions I have from parents is, when can I start using FMT? And the problem is that FMT is not approved by the federal government for C. diff. It is allowed. It's not approved. It's never gone through phase 1, phase 2, phase 3 trials, because only recently did the FDA figure out that they decided it was effectively a drug. So because there's over 25 studies showing its high degree of benefit for C. diff, they are allowing it for C. diff, but only for C. diff. Because it's allowed but not approved, that means your physician cannot use it off-label as they can an approved medication. Does that make sense? Okay, so what is the risk? Well, FMT has been used in over 5,000 cases by just one of my collaborators alone. The risk seems very small, but that's because the stool is screened very, very carefully. The donors are screened very, very carefully. There are standard procedures for this. So perhaps someday we'll be able to get to the situation where we can find out there are a few particular bacteria of interest. But I think the reality is we really need a full spectrum product, because this child is missing this several hundred bacteria, this child is missing this several hundred bacteria, but they're different and they have different pathogens in them. It's clearly not one pathogen that's causing GI problems in kids with autism. It's a wide variety of them. That's what our data shows. Another question I get about is yeast. We've done the only study I'm aware of looking at yeast levels in kids with autism, and we found that there's a slight increase, but not statistically significant in kids with autism versus controls. There's a lot of studies showing that antifungals help. Antifungals a lot of anecdotal data, I should say, survey data. But the antifungals played more of a role than just as an antifungal. They also may be anti-inflammatories. So we don't know yet about the importance of yeast. We're doing research on that to do additional studies to evaluate it more rigorously. But yeast also may be a factor in some kids. It could be they have an unusual sensitivity to it. It could be due to intestinal permeability, just more of those yeast metabolites leach into the blood. But we'll just say, using doctors' data, with a large study we did, there was very little difference in in yeast levels in stool measured two ways, both looking at it under a microscope and looking at it and culturing it. Tim Bowie, a top GI doc at Harvard Medical School, has scoped over 1,000 kids with autism. Says, yes, he's seen yeast overgrowth. He's shown pictures of it in his talk. And he says out of the over 1,000 kids he's scoped, maybe 5 or so have had a yeast overgrowth. So it's interesting. It's something we need more research on. How am I doing on time? 2 minutes, okay. So I'm just going to stop there and thank you. Thank the Arizona Board of Regents for funding this, our local ZooWalk for funding it, our collaborators at Cristovo and the University of Minnesota for providing the microbiota, and our Walgreens for compounding the Vanco for us. I'm happy to answer any questions you have, and you can also email me too. Yes?
Thank you for doing this wonderful work. I think this is a real, very significant area in the future for our kids. I happen to be a mom of a child who is one of those kids that has really low diversity percentile. 19th percentile you hear me?
Yes. So you said you have a child who has very low diversity of gut bacteria. So I'm going to give you a very personal example. I have a daughter with autism, 25. She had some GI issues when she was younger, doesn't have them now. But when she was very young, she had 14 different courses of antibiotics during her first 3 years of life, 7 different antibiotics. We wiped out virtually every bacteria there was to wipe out in the gut, didn't affect the ear infections. Horrible mistake. I didn't know what I do then. A lot of different nutritional interventions have healed her gut, but when we measured her gut diversity, it was lower than any one I have seen in any one of our studies. And so I am planning to do an FMT treatment for her, and I'm asking the FDA to do a special single patient IND just for her, because my hypothesis is if she's the most extreme case we've seen of someone with moderate to severe autism and intellectual disability, no GI symptoms, but extremely low diversity. So we will at least be able to improve her gut diversity. Will that improve her symptoms? We'll see, but that's the hope. So I think that may answer your question.
Oh, actually, that was just a comment. That wasn't my question.
Okay. I'm sorry.
My question was, in your study, did you try to do any characterization between the responders and non-responders based on either stool metabolomics or DNA sequence?
Yeah. The problem is almost everyone responded. 16 of the 18 kids responded 70 to 100% in terms of GI symptoms. Only 2 were non-responders. So we just don't have enough statistics to see what's different about those. What I can say is, I think I forgot to mention, Prevotella, which I talked about earlier, was low in the kids with autism. It went up dramatically after treatment. It went up 80-fold, if I remember right. So dramatic increase in that. But we just need a larger study to answer that question. But I think also as we go to higher dose and longer duration, we may get an even higher than 90% benefit.
Dr. Adams, I have a question here on WhatsApp. For all of you, by the way, we'll prioritize the questions coming here. If you need to add yourself onto WhatsApp, you can talk to Kritika, and maybe you can position yourself so people can reach you. So Dr. Adams, could you please talk about the bowel prep needed to receive NTT? I'm wondering about performing this in younger children. Thank you.
Yeah. So we do plan a study in another study in young children. What we did in our study was we used vancomycin, which is very safe because it's not absorbed into the rest of the gut, into the rest of the body. It only stays in the GI tract. It's a very powerful antibiotic. It's certainly killing off a lot of pathogens. It's probably somewhat worsening killing off some of the beneficial bacteria too. On balance, it's probably good, but we don't think it's ideal. So we're going to experiment in our next study with some children not receiving the vancomycin and doing just the MOVI prep and see if that's sufficient. So we'll find out. The honest answer is we don't know.
I have another question here. In future studies, will you be looking at immune parameters, metabolomics, and proteomics?
So in our last study, we did do very extensive metabolomics. I don't have time. I'm not allowed to talk about it yet because it's published. I'll just say it's incredibly exciting. We'd like to do metabolomics in our next study, but it's very expensive. So if someone can give me a couple $100,000, we'll do it. Otherwise, we're saving the samples until we can raise that money. So yes, we think that's a very, very important area.
Another question here. Do you have data on the test subjects' exposure to antibiotics?
Yes, in our FMT study, we were surprised that there was not a major difference in oral antibiotic use in our FMT study between the autism kids and the typical kids. But that was a very small study. In our several previous studies, which were much larger, we did see a difference. But in this particular study, it seemed the major difference was low fiber intake and C-section at birth were the primary risk factors and not antibiotics.
Sorry, what was the last word you said?
Not antibiotics for those particular children.
How would you interpret variable poop in kids? Some days well-formed, some days more watery?
Yeah, so I really want to go back to that picture. I urge every family to do just what we had parents do. Every day, they recorded if their child had a bowel movement and which type it was. Many of the children in our study were ages 7 to 16. The parents did not normally ask their child, so how was your poop today? It wasn't a normal question during breakfast for some reason. And so the parents said after they did a 2-week evaluation, they had a much better understanding of the severity of their child's GI symptoms. So I urge every family to do just what we did, track your child's stool for 2 weeks and see what you observe, because that's the only way you're going to know.
Are there any questions from the audience?
I think we're over the 2 minutes, but let me know when you want me to stop.
Do you know if FMT is being done legally in any other country?
FMT is legal in the US for C. diff. Tom Barodi is using it in Australia. He's treated over 5,000 people for a wide variety of GI conditions. But he's only able to do teens and adults. I don't know about every country out there, though. Sorry.
Do you have data on immune parameters in the kids in the sample? For example, the parameters that influence the regulation of the gut microbiome long-term, like total IgA?
Yeah, it's a great question. We did our initial study on a real shoestring budget. So we tracked CBC and ChemPanel. And so this gave us a very good sense that there were no major problems. There were no worsening of blood cell counts. But we did not go to that level of detail. I'd love to do that in a future study, but again, it's just more cost. And we don't have the budget for that at the moment. But we'll collect additional blood samples in case we do get extra money. I think you raise a great point that we believe there's a very strong connection between the immune system and the gut. I think I forgot to mention that when we looked at the medical histories of the children with autism, they had a much higher rate of food allergies and environmental allergies compared to the typical children.
A question here on WhatsApp. Any data on how much parasites are involved besides just bacteria?
Yeah, so in the first study we did back in 2011, we measured parasites using doctors' data. They're one of the best labs because they look at them very carefully. And out of the first 20 samples, we found 0 parasites, so we stopped looking. It just wasn't present in a significant number of cases. Now that's in the US. There might be other parts of the world where it is present.
Yes, I had a question here in the audience. I'll take maybe 2 more questions.
This is on the very basic side.
I'm wondering if you can give people here a sense of what the most reliable route is for testing levels of microbiome diversity, and what the most reliable way of just testing for the vitamin K and biotin might be, if you're dealing with a regular primary care physician and want to evaluate it.
Right. So I'll answer that in several ways. For parents, I think the best, most practical test is to look at your child's stool, because half of the stool is gut bacteria. If it looks bad, if it smells bad, you have bad gut bacteria. It's really that simple, and I think that's the most reliable test that is easily accessible. Now at our lab, we can look at how much of every single strain you have, and Second Biome has that capability, and a couple other labs do too. But we don't know how to interpret that yet. We know how much of every single species is present, a relative abundance of every single species, but I can't tell you what is optimal yet. We don't have that level of knowledge. So it's not that a bacteria is necessarily good or bad, but it's what's the right level, what's the right balance. Everyone has a little bit of C. diff. Question is, how much? And so for vitamins, there are a few labs. We worked with Health Diagnostics for measuring vitamin K and biotin. But rather than spending that much money, I would say just use a vitamin mineral supplement. But again, I'm a little biased. I am president of a nonprofit that produces a vitamin mineral supplement you'll hear about, but I don't get any royalties from it.
Is there a particular one?
Particular vitamin mineral supplement? I'll give you my recommendation, but it's coming up in my next talk. All right.
At 3:45. Last question here. Would you look at chronic subclinical infections using metagenomics in future studies if funding were available?
Yeah, so we would love to do metagenomics. What I think is more important is metabolomics and metatranscriptomics. Metagenomics tells you what genes are present, but it doesn't tell you if they're active or not. What we really care about is what is being produced. So I think the metabolites are much more important. Based on the data we have from our phase 1 study, I can tell you, is this a child with autism or is this a typical kid just from their blood, the metabolites in their blood. It's very clear. And so I think metabolomics is very important.
Sorry, that was my question, if I may clarify. I was
Sure.
asking I meant metagenomics on cell-free microbial DNA, like carriers or Charles Chu's lab, if UCSF is doing.
Yeah, so that's something we would love to do. Again, it's just a question of budget. That we have, even though $1 million may sound like a lot, for a clinical trial, it's peanuts for what we're doing, and we have to follow all the FDA regulations and guidelines. So we are collecting additional blood and stool and urine and buccal swabs to look at mitochondrial function. We suspect that may be important. We are looking at natural killer cell activity, but we'd love to do that. It's just a question of money. Yeah.
Well, thank you so much, Dr. Adams, for that highly informative talk today. I wanted to make a few announcements. Many of you have this Turnabout for Autism. If you don't have it, there are nicely bound ones that are available. The other thing I want